Welcome to Hazy Choice Extra Credit Project. I'll start with question number 2. What is the enthalpy change for the combustion of hydrogen sulfide according to the following chemical equation? What I forgot to do during the test was to balance the equation. So this time I balanced my equation and I got 2H2S, 3O2, 2H2O, and 2SO2. From this balanced equation, I can find my enthalpy change that the question is asking for. Recalling what we've learned during class, the equation to finding the enthalpy change is the sum of product minus the sum of reactants. If you extend this formula, it will look like the one below. 2 moles of H2O from the product plus 2 moles of SO2 minus 2 moles of H2S from the reactants plus 3 moles of O2. When you actually plug in the numbers of the values which are in the chart that was given during the test by Mr. Brown, you will end up figuring out the value of the answer. It is negative 1124.2 kilojoules. That will be the answer. Next, we have question number 5. What is the change in entropy for this reaction? Again, I made the same mistake like the previous question. I forgot to balance my equation, so I did this time. 4 aluminums plus 3O2, and I got 2Al2O3. The equation for the entropy change, it has the same concept as enthalpy change equation, which is the sum of the product minus the sum of the reactants. If you extend the formula, it looks like 2 moles of Al2O3 if you look at the product minus 4 moles of aluminum plus 3 moles of O2. If you actually plug in the numbers that you get from the chart, you end up getting the answer, negative 626.2 joules per Kelvin. And that will be the answer to this question. The question to number 6 is, if a block of warm iron weighing 50 grams is placed in 100 milliliters of water and the water's temperature rises from 5 Celsius to 19 Celsius, how much heat was absorbed by water? During the test, I tried to find the temperature, the heat that was absorbed by iron. I was trying to calculate directly with iron, but that's not true. I was supposed to calculate with the mass of water. So the basic equation to finding the heat is Q equals to NC delta T. We were given with the mass of water, which was 100 milliliters. We could change that into 100 grams because it's water. And delta T, we can find delta T through knowing the final temperature minus that with the initial temperature, which was 19 minus 5. We get 14 Celsius, or it could be 14 Kelvin, because when it comes to difference, it doesn't matter. And the molar heat capacity of water, which is 75.3 joules per Kelvin mole. We need to know the N. We don't know it, but what we only know is the mass of water. With using that, we could find the number of moles. So 100 grams of water times 1 mole of water over 18 grams of water, we get 5.56 moles of water. We plug everything we have into the equation, and we get 5,861.35 joules. We can change that into 5.86 kilojoules. This is how much heat that was absorbed by water. Now, number 7. Which of the following is an extensive property? We have density, temperature, pressure, and enthalpy, and none of the above. But the answer is actually enthalpy. Why? We have to ask ourselves, first of all, what does extensive property mean? Extensive property means properties that actually do matter with how much you have, with amounts. Density, temperature, and pressure do not have to do with how much you have, but enthalpy do matter with how much you have. Depending on how much mass you have, enthalpy can go up or down. So the answer would be D, enthalpy. And finally, question number 10. If you burn 50 grams of ethanol and it causes a temperature increase of 23.5 Celsius, what is the molar heat of combustion of ethanol? Well, before we start solving this question, there is something that's not mentioned in the question. 100 milliliters of water was involved during this burning of 50 grams of ethanol, which shows the temperature increase of 23.5 Celsius. Then, we have two steps to this question. First, we have to solve the heat that was involved during the burning of 50 grams of ethanol, and then with the heat that we solve, you have to divide that with the moles of ethanol that was burned in order to find the molar heat of combustion. Okay, so the first step, we have to find the involvement of heat. So the equation would be Q equals to NC delta T. We do not know N, but we know the mass of water. So we can use the mass of water in order to find the number of moles. So we have 100 milliliters, which could also mean 100 grams. So 100 grams of water over times 1 mole over 18 grams, which will come out to be 5.56 moles. We plug all of this into our equation and we'll have 5.56 moles as the N, 75.3 joules per Kelvin mole, which will be our C, the molar heat capacity of water, times 23.5 K, which was the temperature change, and we'll get 9.84 kilojoules. Our second step would be to divide our heat involvement of water over the number of moles that was burned, number of moles of ethanol that was burned during this process. So we have 9.84 kilojoules divided by 1.136 moles, which was solved here. N equals to 50 grams of ethanol times 1 mole over 44 grams, which I solved by using the given grams on the board written by Mr. Brown. That comes out to be 1.136 mole. So 9.84 kilojoules over 1.136 mole would come out to be 8.66 kilojoules over mole. This would be the molar heat of combustion for ethanol. And thank you for watching.